All right, yeah. Thank you everyone for coming. This is just a wonderful sight to see a full room. This is awesome. Just to give you a heads up, we are recording the panelists here, and we're also recording the audio. We're not intentionally recording any audience members, but if we do catch you on a video, we'll blur it out. Hopefully that doesn't cause any issues, but if it does, just let me know. My name is Zennith, or Michael if you're doing in real life stuff, but I go by Zennith, have a PhD in biological biomedical sciences. This is Keiro.
My name is Ramon Reyes. I work at a certified system administrator.
Yep. And we are both representing the Freedom of Form Foundation today, and we're very excited to be here and show you what all we've been up to. And this is something that many of us, I'm sure, have dreamed about. It's a mission that's pretty close to our hearts, and it's something we're referring to as freedom of form. Freedom of form is meaningful to a lot of people in various ways. Several years ago, as we were just getting started, we learned that a lot of furries and a lot of Therians and other groups of people really want this. Occasionally you'll catch like jokes like, "Oh, what if you're your persona?" I mean, it's like a lot of people actually want this, and it's worth taking that seriously. In fact, 79% of furries in a recent First Science survey said that they would be said yes to the question, do you wish you could be something other than 100% human? So the idea of morphological freedom, or freedom of form, is that you determine what your body looks like in a way that suits you. People have their own goals and reasoning, including identity affirmation and self-expression. But something that really stuck out to me, these are some quotes from our community Discord server. This one in particular really stuck out to me from an anonymous user. To me, freedom of form is not being what you want to be, but to express what you always have been. So, people have their own reasons, but that one in particular just really struck me as, really deep and enlightening. So we embrace the variety of goals and motivations that people have, and we're working on the technologies to make it all possible. After a few slides here, we're going to take a small break, open to questions. Then we'll open to questions again a couple slides later, and then again. And then at the end of the presentation, we'll basically hopefully have 15 or 20 minutes of open questions as well. So just to kind of, mention that. Okay. Where do you even get started? Like, yes, people want this, but this is also a very difficult challenge, of course. But if you're systematic and you start to see where the challenges are, you can start figuring out where to solve them. This is just a ref sheet from one of the server members, who goes by Fel49 or Galloway, and I think that this is pretty representative of what a lot of people are going for in terms of overall look and feel. Obviously this is very much non-human, but if you start breaking down the various things that are going on, you can start to see some ideas of the tissues that need change, as well as potentially the technologies that might invite themselves to accommodate those anatomical changes. So, for example, just to go quickly here, the muzzle, for example, obviously there'll be the mandible and the maxilla. Maybe some other facial changes with some of these other craniofacial bones. Sphenoid, if anybody is a fan of cranial anatomy, that'll probably be changed a little bit. Obviously the sacrum and coccygeal area will also need some degree of change, just because like the sacrum is a merged bone, and you'll have to kind of break it apart a little bit and have something that can wiggle. Fur, obviously, or feathers or scales, that is also another big thing, and we'll go into more details about that a little bit later in the presentation. And then, obviously the foot bones as well. You got the metatarsals and you got the phalanges. Those will need some degree of lengthening, and you'll also have to have some adjustments in terms of muscles and the tendons and ligaments that are in that area as well. So this is all still very 30,000 foot view, but even here we can start to see, in general, an approach kind of writing itself. So then the question is, how do you engineer it? And the answer is to kind of take a page out of the engineer's playbook and just write a lot of documentation. So, we probably don't need to go into too many details about this, but one of the ways that we're approaching this is by writing a pretty large requirements document. This one thing is 13 pages, and we'll probably have something a couple hundred pages total when we're done. This is all a mess, but the major intent is that we are basically describing in formal and comprehensive terms what we want. And I think that this is a big deal, because if, for example, you have several types of fur, because this is a requirements document for the body covering. If you have several types of fur, and then you break that down into the various types of fur that you're going for, you can describe what would be successful fur, what would not be successful. And by getting into really specific statements, then it's basically just a really useful exercise to have the technologies write themselves and accommodate those performance criteria.
And also to have a base to work off from.
Yes, exactly. So this is all going to be some living documents, and we'll keep on coming back to them. We've already been looking at them a little bit. But the overall thing is that this set of living documents will help us identify and prioritize projects that solve various anatomical challenges. And a big benefit of this is that some fur, for example, in this example, some fur will be easier than other types of fur. And what that lets us do is we can say, okay, we have some solutions for this particular type of fur. That goes. We can go ahead and make some people happy. And then some other more difficult types of fur, like say more vibrant colored fur, that is a little bit for later, just because we're expecting a few more challenges with that. We still want to make those people happy as well, but in terms of triaging this, so to speak, we just have to defer some of those things for a little bit later. That documentation, it's a big thing, but at the same time, it's a lot, and we don't want to wait for it to be done before we actually doing projects on the ground, so to speak. And a lot of the reason as well is that we've already done a lot of the thinking, a lot of the planning that we'll ultimately use. The documentation is like a formalization of that, but we already have a decent idea about some of the important challenges. And we have projects that are ongoing to accommodate those. And we'll talk about these two projects a fair bit, the 3D and animated CAD project, as well as the integument review. Something that we won't have time to talk about today, but I'll just kind of tease it briefly, is the enhanced tail. And that is a project that aims to develop sensory control of motorized tails. Basically means you have some sensors on your back that detect what your muscles are doing, and then help you control the tail in a natural way. A couple pretty smart engineers on that, so we'll see where they go. But unfortunately, I can't really show you anything about that today. And overall, with these projects, and honestly probably a couple others that will start at some point, we're taking on some of the most important technical challenges already. Yeah, we can actually stop for like a question or two at this point, if there are any.
Raise your hand if you have any questions.
So I actually do have a question. So are you going just whatever method possible to create a result, whether it's biological, mechanical, or such?
Yeah, exactly. That's actually one of our key takeaway messages, is that our organization itself is not really opinionated on which technology winds up winning, or if several technologies wind up winning. There are some people in our community who are more attached to one technology or another, and we're perfectly happy for them to be opinionated. It's just like the people who are highly opinionated about one technology or another is relatively smaller. So in the sense of triaging, that is a little bit less weighted, if you will, just because if you can't tell what technology is being used for any particular result, then it doesn't really matter. If you define not being able to tell as like a really convincing test of can you even tell if this thing is biological or mechanical? If you really can't tell, then philosophically we don't really have a horse in that race.
Yeah. But in those cases, it's going to be a while until you get to that stage.
Yeah.
More than likely, we're going to start probably heavily mechanical. We already are starting almost completely mechanical right now.
Yeah, yeah, exactly. One more question?
This might be a bit more technical than the actual what we have time for, but considering how even just regular, say, human organ donation has these pretty heavily immunosuppressants, and the organ itself usually only lasts for 10 years, the transplant. Do you have an idea of, maybe this is, like I said, too grandiose of an idea to think about right now, but what kind of...
That's a question for a later time, I would say, personally, because that's a research that still need to be done. We're still in the pretty early stages of research, particularly with regard to freedom.
They actually did an experiment recently where they actually grew an organ in an animal, and they actually did put it in a person to test it. So they're actually slowly getting beyond that stage already.
And they're also growing organs in terms of like a 3D printer kind of style platform too, and just because if we have those issues with standard genetic.
So is your concern about the immune response?
Ultimately, yeah, it's an immune response, and also making sure that any sort of purely biological or biomechanical augmentation of fur and stuff does not otherwise cause
Scarring,
new types of cancers, even the idea of fur. It's like, well, how are you going to have to re-engineer sweating and other stuff like that? How are you dissipating heat?
So that is getting. Those are great questions.
Yeah.
We are including some of them in our requirements documentation. Your point about heat management, that's in that document. Your points about immune compatibility, I would say that we're not super concerned about it because we're planning on patient-derived IPS stuff as one of the possible approaches. And in terms of scarring, this is personal opinion, but I think that if you do it carefully, you'll be fine. A lot of the observations of scarring are if you're using like metal needles poked in tissue, and of course it's going to cause scarring.
As a point across, I have a pretty big scar here.
Oh boy.
And it's, so the crowd can see.
Yeah.
And it does cause some issues with mobility and stuff. That's, scar tissue, that's kind of how it
Yeah.
works out. So,
Yeah, I can definitely imagine.
So,
Are you
Like I
also
said,
referring to
these questions are
stem cell
probably
research?
too outside the scope of the presentation right now, but I think it's good to think about.
Yeah, I definitely agree with that. Yeah, we probably need to keep moving.
Yeah.
Okay.
Okay.
All right. So what would this actually look like for a patient? We got all these plans, but how would you, ultimately, with whatever technologies we have, how would this actually wind up being applied to a patient? So the answer is basically you're going to start with some type of medical imaging. This is a CT scan of my head that I just had lying around, as you do. I feel like that's pretty normal. And then you also have like a ref sheet or something, preferably not a pool toy if you're doing something like remotely realistic. So this gives you like your start point in terms of raw data, and then your ending point in terms of raw data. Then you need to, really just process this into like a model that is detailed enough for like surgical planning, basically. Because no surgeon is going to look at just one image and then plan surgery. They need to see an integrated representation of all the tissues that are of concern.
For example, I am also a surgery recipient for a cochlear implant. A lot of planning goes into that just for having the cochlear processor set up, and there's a lot of details. CT scans is just one part of it. There's also other parts where you need to consider the weight, the health of the person, and whether or not it's a good risk to have that happen for you. And
Yeah.
that's one of the things that we're working on for you.
Yeah, exactly. And that is like ultimately what this, once you figure out what all things are getting changed, presumably through some number of intermediates, regardless of the technology, there is planning that has to go into that. And we can't really give you all the detail of that planning yet because there's still so many questions. But what we can say is that you need something to represent the start point and something to represent the ending point. This is not necessarily clever or anything like that. It just, it's just kind of revealing itself as a thing to do. And basically our goal with this 3D anatomy project is to represent the start and end points. And we have some detail about this. So our computer-aided design tool is expected to be a critical piece of software to flexibly and customizably describe all the relevant anatomy, a core need of planning a TF procedure. TF for transformation, I'm sure that's a well-known acronym here. Yeah. And a lot of the needed customizability, especially early on, will just be modifying the shapes and sizes of existing structures, such as bones. Obviously at some point we would like to let people add wings and other things, but in terms of making this CAD program work, a lot of it is just representing some more basic things in a insightful way. So if you have to make a bone longer or shorter, for example, like the foot example we talked about a couple slides ago, you need longer metatarsals, you need longer phalanges of your foot, and just saying you need longer bones is not really helpful. So what I mean by that is if you just make that bone longer, then you wind up with something on the left panel. And what this means is that these kind of ends of the bone are no longer appropriate for the joint. As well, you've basically just messed up all of the muscle binding sites that would be along the bone. So you can't just like scale it and then use it. Instead, you need something like what is on the right. If you want a longer bone, then you make the shaft of the bone longer, and you respect the biological function of the joints as well as the muscle binding sites. Obviously, there's a few caveats here. We don't really have time to get into those. You would have to like increase the thickness a little bit alongside like scaling rules. But the point is, you have to do it in a way that follows logic. And that's like the core intent of this program that we're working on. So, you know, we've got a couple really smart people working on this, and like honestly, they've gotten to the point where I don't understand what they're doing. So I'm just doing my best here. One thing that they're doing is using bio-inspired design to represent what all of these how all of these like anatomical parts integrate with each other. And a great example of that is the site where a muscle anchors onto a bone. So biologically, if you have a muscle joining up to a bone, and an example that we always use is the deltoid tuberosity. For reasons I can't explain, this is again one of those things that's over my head. If you have a larger deltoid, then you wind up with a larger deltoid tuberosity, that is like the site on the bone that it binds to, just because the muscle during embryonic development causes a higher amount of strain on the bone, which literally pulls it out while it's still soft, and then you wind up with like a larger bulge. And basically that means that as a consequence, your bone is better adapted to undergo larger amounts of stress or force. And you'll have relationships like this like all over the body. And the point here is that you have to understand what embryonic development, what evolution are doing to change the relationships between muscles and bones and other tissues. You have to understand the intent, at least to some degree, before you try engineering it, or you'll just wind up with a bone that breaks for ridiculous reasons, and that's no good for anyone. Yep. So in terms of where the project team is now, our team has focused on really two different things. First of all, determining how those anatomical shapes are formed, and then figuring out how to describe those shapes in a way that makes sense on a computer. And this slide is showing one of the big ways that we settled on representing how joints are made. So your humerus's elbow joint is basically like the humerus itself forms a hinge, and then the ulna kind of rotates around it, and the ulna forms a cup that just like fits around it really nice. So we're representing that as a constraint that is kind of rotated, if you will. And if you combine that with a few other constraints, then you wind up with something a little bit more on the right here, which starts to look pretty biological. You know, this is still a little bit, you know, kludgy, if I'm honest. There's still a little bit more optimization to be done in terms of the like curves that we're using. But the point is, these are multiple constraints that are influencing the mesh's design, and a artist has not like adjusted any vertices or anything. This is all just done by constraints. And this is, I think, one of the coolest things about the modeling approach. So let me hop out here and just, so this is just like a thing that the team lead Lathrius gave me earlier today. This is only one bone by itself. The constraints were applied to it. You just can't see the constraints right now. And you know, there's nothing super exciting going on with this. It's just to say that this code base that we have is compiled. It's running on the Godot engine, and we're pretty close to the point where we can start adding the ulna and radius and start really fleshing out the full elbow joint. And from there, it's just a matter of adding more bones, and before you know it, we'll wind up with a full creature of some sort. So, that's just something that we've got going on, and I think it's really cool. All right, so that is actually the end of this section. I think that we have time for one question. In the back.
What curated design software are you guys using?
This is all literally self-wrote by people in the organization. Yeah, like no other CAD tool does stuff like this. We did look pretty thoroughly. There's some things which get like 10% of the way there over here, then 10% of the way over there, and it's just like, no, we're going to write it. Yeah, and they're doing a great job. All right, so this is the other big project that I want to feature today, and that is the Integument Review Project. So Integument, I think maybe 15% of the people in the room have used that word at best. So the integument refers to the coat or covering of animals, and that includes skin, fur, feathers, and scales. And the team is aiming to understand basically everything about how the integument works and figure out ways of engineering it. Obviously animals have highly diverse and visible integuments, and they're just really important to visually representing a species. So for examples of how varied this is, you've got a cat and a canid over here. They've got various types of fur, some whiskers as well. The fur varies a little bit between the like dorsal and ventral aspect of the animal. Over here, you've got various types of scales. It's not just scales. You've got various types of scales, like the snake. I want to say that these are both roof tile type. Then you've got like the more crackly appearance of like turtle scales, for example. Then you've got birds over here which have both a lot of different types of feathers, and these are just like some types, and they also have scale-like coverings as well on their feet. So this is a lot going on, but you can basically say that the integument is maybe more like a set of complex systems rather than just one really complex system. And if you say that it's a set of systems and treat each one as its own thing to be engineered, then you can approach it in a more rational and collected way. So this is also not my area of expertise. I was provided this, so I'm probably doing a bad job of explaining it. But the integument team has put together this summary of a lot of the mechanisms that are going on in these integument types. On the left, we've got fur, and that's defined by the hair kind of arising out of the dermal papilla. And really the interesting properties of fur are determined by these regulatory factors here. So these are called like morphogens. They are molecules that are secreted out of cells, then influence what other cells are doing. You got Wnt, BMP, FGF. Does anybody understand what I'm saying? Has anybody heard of FGF before? Wow, a few people.
A perfect example of this is you would consider this as breeds of animals with soft fur, horse fur, smooth fur, things like that. That's similar in concept.
Yeah. So like the different secretion and influence of these molecules will have a hand to play in determining like the what type of fur actually winds up getting formed. So that's a really big deal. There are also mechanisms that are at work in feathers. There's this restructure here, some stem cells, and feather like length is determined in part by this this patterning, ectodiplasm. You've got cycling behavior, which, if I understand correctly, is like periods of either growth or shedding and then regrowth. I could be wrong about that. That's embarrassing. And then finally, you've got scales here, which have a few properties in common with the others, even though they are obviously very different in shape. So that's actually one of the interesting things, is there's a lot of homology between these different structures, even if they look pretty different. You've got a little bit of ectoplasm signaling, you've still got Wnt, everybody loves Wnt. And actually, interestingly, and this is actually really important in terms of engineering, there was a study, and I can't give you the citation for it, but they basically turned feathers into scales, then scales into feathers, and yeah. So we've got these transcription factors, like SOX2 is something that cells get and then figure out what to do with it. Transcription factors are sort of thing where if you understand it, you understand it, and if you don't, well, it's just you really don't need to. They're molecules that do their own thing. So the big takeaway message here is that while the specifics will differ, it seems pretty reasonable that by using this and similar knowledge of biological signaling, we can ultimately get these systems to behave the way that we want. So that's really the takeaway message from this. This is the worst watch I'm never going to. So in terms of what this would actually look like, thank you. Oh, we're actually not doing too bad. So in terms of what this would actually look like, how would you actually use this knowledge, this complex biological soup of signaling, to engineer something like a fur coat? And here is one example of a reasonable way that might let you do it. This is speculative. It was put together by Tilt Wolf based on him and his team's knowledge of this. But one possible way of doing it is you get patient-derived induced pluripotent stem cells. You do some sort of gene edits outside the body using maybe CRISPR or something better. You use some specific Wents, this DICOP thing, FGF, and you use those to kind of control their differentiation into a couple of different cell types which are used in the follicle. Then you combine them in a co-culture. This might be just dissociated cells, or it might be like a structured culture. I honestly don't know, and it might be the sort of thing where we just try both anyway. Then ultimately you wind up with either cells or a formed follicle that you then implant in someone. And then you do that times like a few thousand. So there's actually a little bit of precedent for that. It's not like you'd be injecting one follicle at a time. You do it like times 100 or something. I'm not too sure of those details either, but there are apparently ways of doing it really fast. So, again, like this is just like one possible flow chart. So in terms of how you ultimately arrive at something like this, that is basically the stage that we're at now. So, going back to the idea of having a roadmap, we might have like 3 different flowcharts kind of like this in mind with different technologies that we'd like to try. And then in the process of developing those, we'll basically try like this arrow as a project. Then we'll try like this arrow as a project, and so forth. So there's like definitely some technical risk here, but at the same time, this is all pretty standard biology, and because of that, it's not really like a strategic risk or anything like that. It's just like standard issue projects. So basically, it becomes a task of connecting the dots. Big dots, but it is still just fundamentally connecting the dots. And this is just something that the Integument project team is working on, and they will continue progressing and like probably adding members to the team, and then eventually getting to the point where they can do the wet lab experiments to test these hypotheses. And I've been told not to speculate on timelines, but this should be doable in a reasonable timeline. I've been told several times not to speculate on timelines. Yeah. So I think that we have
Mud or valve time?
Sorry?
I'm just referring to the timeline.
Oh, yeah.
Mud or valve time?
I don't think I should even speculate on that. So I think that we have time for one question.
What?
So I noticed in the sort of setting up the talk, you mentioned you had spoken with Hugh Herr, who is one of the MIT Media Lab directors and generally considered amongst the field of biophysics to be the preeminent scholar in human-machine interfacing as it stands today. How did that conversation go?
I was not in that conversation. That is a great question. I'll refer you to.
So what was the name of the person?
Hugh Herr.
H-I-R-R?
Herr.
The
Yeah.
MIT Media Lab is it's like an big umbrella group that has effectively a blank check. Because he is so good at what he does, they effectively allow him to do whatever he wants. You can find his TED Talk. He's a double amputee, and he designed his own robotic leg. The most interesting thing that has come out of his lab as far as the field of biophysics is concerned is that he has a channel that is meant to be implanted in the base of the spine to allow for greater nerve conduction in spherical lesion patients. From my understanding, that has entered phase 1 clinical trials. And they have implants in someone where they're able to return thermal and cold sensitivity to the individual.
That is fantastic.
Your Twitter followers.
I did recently hear about technology about reconnecting a person's spine. That's one of the interesting technologies that's being researched. It's pretty early stages, but they said it was pretty promising.
Yeah, this is all like really awesome to hear. You can probably tell that I'm not really the expert at any of these things. Like a lot of time I'm doing like administrative stuff, but that is definitely really cool to hear. It's really exciting. The first clip that I want to bring up is a clip of an interview that we had with Andrew Sandberg. Just a big point in general of making sure that freedom of form actually happens is by reaching out and talking with people. A lot of thinking has already been done about why morphological freedom is a good idea, and we can work to learn from each other. So that's really the overarching theme of these interviews. So one of the first interview that I'm showing right now is with Andrew Sandberg. Andrew Sandberg is one of the world's leading scholars in the principles of morphological freedom. He is a professor at Oxford's Future of Humanity Institute, and he's really one of the founders of this field, along with several others.
As individuals, and how do we have a right of morphological freedom?
Yeah. So I wrote my essay on morphological freedom way back. I think I did it in '99. And back then I was very much into this traditional rights framework. Well, it's totally obvious. I have a right to my life. I have the right to my freedom. From that follows that I must have a right to my body, and then I should have a right to update my body.
Yes.
Relatively straightforward, except then I started studying philosophy and realized rights are not that easy at all. Indeed, as Bentham famously said, they're nonsense on stilts. Now, the problem is many of the ideas about rights are hinge on quite dodgy philosophical foundations. In practice, rights work really well.
Yeah.
We declare something a right in society. That means it has to be respected. We set up laws and institutions that protect it. And as long as we more or less agree that this makes sense, this works fairly well. And I do think there are pretty profound moral reasons why we should have morphological freedom. It's just that it's going to take a fair bit to get everybody in on that and show that this follows a lot from the other stuff we're allowing people doing or even obliging people to do in society.
Yeah. So when you wrote your book about morphological freedom. You said that was back in 1999, was that?
Yeah.
I think you may have been one of the first to actually develop that as a term and make it a thing, so to speak.
Yeah, Max Moore beat me to the actual use of the term, and in roughly the same sense, of course,
Right.
some years earlier. But yeah, I was probably among the first to really start thinking, do we actually have some proper form of right here? And how does that then work in the bioethical debate?
So there's a lot more of that, and we've got the full interview on YouTube, and it's a really good watch. But yeah, that clip with Andrew Sandberg just really stuck out to me as being really representative and interesting of his viewpoint. So yeah, it was really cool that he agreed to meet with our vice president Atta. That was just like a really cool talk. Okay, so we'll have to do this next one a little bit quickly. This next one is with Liz Parrish. Liz Parrish is a pioneer of gene therapy self-experimentation. She got into a little bit of a squabble with regulators because she injected herself with some kind of telomere lengthening treatment. She is CEO of BioViva Science, and she's just a advocate for patient autonomy and patient choice. So there were a lot of really interesting points in this interview, and I can only show you one, I'm afraid, but it is still a real treat.
Then, I mean, challenging people is a really important thing to do, right? That's really important. It's really important to challenge people to think bigger and to think better. But if we don't have morphological freedom, which I would argue we really don't have right now, I mean, it really should be a human right. It has to be. It has to be written in as a core concept, even to achieving the most simplest things in health at this point.
I do need to skip another quote that is a little bit longer. I'm going to refer you to the full interview with Liz Parrish as well, because it's really excellent. She has some great tips on entrepreneurial activities and basically finding your passion. Would highly recommend that as well. Then the final thing is with Max Moore. Has anyone heard of Max Moore? No. So Max Moore is relatively big in the transhumanism circles. Let's see. He basically invented the term morphological freedom. In fact, in like the early and mid 90s, he's widely known as well for his efforts in enhancing and transcending the human condition. He's also heavily involved with Alcor life extension, which is like it's one of those more out there transhumanism things of you like freezing your brain and then getting revived later as an idea. So not getting into that, but he is a pretty prominent transhumanist in general. So it was also a real treat to get a conversation with him.
So how do you react to those naysayers who criticize transhumanism as being unnatural or in some kind of negative light?
Well, yeah, there's a whole bunch of different objections, really. The unnatural one I just find kind of a little bit silly. What is natural for human beings? If you mean by natural something that is part of nature without human beings, I guess we're going to have to go back to the caves, not have any fire, just live in animal skins, and that's pretty much it. That's natural. But that's kind of ridiculous, right? I mean, beavers build dams, so you can't say that dams are natural. That's part of what being a beaver is. And to me, a core part of being a human, this comes from humanism, is the idea that we are questioning beings, we're creating beings, we build and create and develop things, and we question things.
So I'm going to stop that there, just to make sure that we have enough time for questions. This is another just like really good interview, and I would highly recommend watching the full thing. It was really exciting, and it was Tilt Wolf who was the interviewer this time. So really cool. I'd highly recommend it. It's on our YouTube channel. Okay, so plug back in.
Oh, did that?
Uh-oh.
It went to sleep and like
It's up.
it's good.
It's up.
All right. Cool. Yep. I mean, this is the only, this is the only slide that we need, so it's all right. So, that really brings us to the end of our prepared content. We exist really because of people like you all. It's a community effort led by passionate people with a vested interest in our mission. And I think that's a really important part, is like, we really want this. And we're willing to do the work to actually make it happen. We don't have all the answers yet, but the problems are solvable. And we also think that there's enough people interested and likely to be impacted to make success possible if we work together. It's an important challenge worthy of taking seriously, and we can do it. So thank you for your attention. I really appreciate it. I'm sure that you really appreciate it too.
Oh yeah, definitely.
Pardon me while I just like put it in your mouth. Yeah, and we're happy to happy to open for more questions. Oh boy. Yeah.
So I know you guys do a lot on the biomedical side. Are you guys currently working on anything for the legal ethical sides?
We are not currently, no.
Okay.
Are
you looking at expanding the organization to the legal ethical side? I mean, of course,
yes.
That's future way down the road, but
yes. If you're offering to help manage it. So that's the thing. It's like, to run a project like that is a big effort,
yeah.
And we don't really have the bandwidth unless we get more management help. So yes, but we can't do it yet.
Gotcha.
Yes, but also no.
So maybe.
All right, next question. Okay. Yeah,
sure.
And kind of two. First, I know you said you didn't want to, theorize on any timelines, but I was just wondering, like, in general, how fast is this progressing, and kind of would I be able to see any of this happen in my lifetime? And also, I happen to be Tauric in that vein. Do you believe that if augmentation were to become a reality within that lifetime, obviously I know it would be a lot more of a challenge to develop an entire second half. Do you believe that it would be able to be retroactively kind of added later on? So like if I was, if we were to become augmented to fully anthropomorphic, perfection, and then later down the line it becomes the possibility of adding that second form, do you think it would still be, compatible, so to speak?
That's a tough one.
Yeah.
The real answer will be, it depends.
Yep.
Technology and research did not take a quick path, so I would say probably not, at least in our lifetime. But within the next few years, next 50 years, who knows?
So the Tauric, I think. Well, you're right. That would be tougher.
Yeah.
I am, I would say, in the median of my personal time estimates, and I think that you would get pretty good anthro results in your lifetime. But I am not allowed to put a number on it. So, sorry.
Yeah, no, it's all right. It's,
Yep.
you know, just general ideas of if I can expect to see progress.
Yeah, yeah. I would be a strong believer in that.
The best comparison with that would be battery technology. Everybody knows how that goes. I mean, how many of you had heard the new tech coming out? We're gonna have longer battery life. Awesome.
Yeah.
I just read
Where
an
is it?
article yesterday that talked about how we finally were able to generate fusion power that exceeded what was put into it. So
I saw that.
we created a fusion reaction that generated more power than it absorbed, which was astounding. I
Yeah.
mean,
As a non-physicist, it looked reasonable.
yeah.
Yeah.
Next question,
I'm
please.
not entirely certain. I just
Oh.
saw it as a general feed, but I'm sure if you looked up, fusion reaction experiments, you probably find various articles on it.
Yeah. Yeah.
Right. Like, I'm not a physicist personally, but all the science stuff, it exhilarates me. And seeing some of these science fiction tropes coming to life before my eyes is just like,
Yeah.
whoa.
Yeah, I'm with you there. Yeah, next question. Oh, goodness.
So you mentioned that you don't quite have the bandwidth to answer some of the biomedical ethical questions or the legal side of things. How big is your team, and how would people get involved? Is that just like volunteer, put money in? How do we find you guys?
Yeah, all good questions. The size of the team, I think, is 29. And honestly, most of those people are pretty active. So it's not just like a big number. It's like, most of those people are legit putting in effort. We don't have many listed open positions on our website, which is freedomofform.org. But that said, freedomofform.org. But to answer your question, yeah, let's like maybe talk afterwards, exchange contact info, stuff like that. I'm sure that we can find something for you. And yeah, obviously money is also always helpful. We're not allowed to fundraise here, and obviously, you should definitely support the Khan charity. But that information does exist on the internet.
We have time for one more question.
Sure.
Yep.
Me?
Yes.
Okay. Is there any, this is more of a speculative question, but given that this is an organization of active individuals and engineers working on this and larger than, it's a team that's greater than 1 to 2 researchers, gosh, you said 29 people, is there any expectation that some kind of movement or organization like this one could incentivize future transhumanist goals to also work together as teams towards, other miscellaneous transhumanist goals that they might have?
The answer to that, I would say, is probably. But at the same time, we're being careful not to overextend ourselves, because something that kind of just gets organizations, just like traps them, is just trying to do everything. And one of the first things that we decided is, the board is all furries, and yeah, and we are not compromising on our central mission. while we are happy to work with other people, it's not to the point where we'll allow ourselves to get unfocused. We're just being overt about what we want and basically prioritizing that. Wherever it overlaps with other organizations, great, we're receptive to it. Yeah, it's a balance. We are out of time. I don't think that we're getting kicked out immediately. Until 9. Okay. So I don't have to go anywhere. So I'm not sure about the rest of you guys, but I don't know. How about you?
I'm up for discussion or any other further questions.
All right. Yeah. Okay. So until we get kicked out, I think that we're okay. Cool.
Any further questions?
Yeah. I saw your hand first.
Yep. Are you guys familiar with the xenofeminist movement at all?
Xenofeminist?
Yeah.
Because
they have a lot of ideas about like the dissolution of borders in gender, and I was wondering how that would apply to the dissolution of borders for like species and a potential like further acceptance of your goals.
I'm honestly not familiar with that. Dissolving gender boundaries sounds great. So sure. I'm just not aware of it.
Yeah, I was wondering if there was any application between the two going on. But yeah, that's cool. Something to look into.
Yeah. I saw your hand.
So I kind of thought of these, as the technology started advancing, you start coming up with ways of actually making these work. I'd imagine there's going to be like thousands of other possible applications besides just making us into our forms. Are you planning on eventually coordinating with other companies that could maybe implement that and then using said profits and proceeds to turn back into this? Is there any plan in that regard?
Something like that. So the TEL project, which I mentioned very briefly, that is some level of a collaboration with a TEL company. You may know the TEL company's motorized tails. They are generally app controlled, and we're collaborating with them to make them more naturally controlled. So I can't say anything about prospective revenues on that, but that is one possibility, and that would be valuable for further development because that sensor integration and motor control logic will be useful for any type of neuroprosthetic as well. So the technology is really what's driving us, and then if we get revenue out of it, great. We do have some product plans for the 3D anatomy project as well, and I'm not sure about the integument, but maybe. For that, I would probably refer you to Tiltwolf. If you're interested, I can share his contact info.
Yeah, maybe.
Sorry, go ahead.
So I, and I'm sure everyone else in the room, are super excited for all of this as a concept, and I'm sure would jump at the chance to have this done. But from a practical, commercial, or even an ethical standpoint, how much do you think needs to be fully complete before application? So let's say you figure out how to give someone fur, but not really any of the other things associated with that, or that you know how to change bone and muscle on the legs, but not so much the other parts, or like the lengthening of a tongue to fill the rest of the mouth, or eyes, or anything like that. Do you feel like it all needs to be complete before application?
Great question. No. Some things will make sense as standalone products. Examples include claws. I've heard requests for claws before. Modified teeth, horns. There's others, I just can't remember them right now.
I would say it probably depend on what the applications are and what interests are available. Because, you know, if a company thinks that there's something, they will jump at it. So we can't really say for sure at this point. It's a bit too early for that.
You know, another important aspect is we have you know, some expectations of market size, which would also make it be pretty reasonable from a commercial standpoint. So you know, that's also a plus that helps the attractability of it.
Next question, please. You'll be next. Okay.
So it's all very interesting, and I can see there's a tremendous amount of effort put into the biology, right? And as a biophysicist, I really want to implore you to look a lot more at the machinery, because I think it's just a much more feasible outcome. I think you've got a lot of great scientists up here. I think someone you should probably look at their work is Doris Taylor, who is at the Texas Heart Institute. Doris works on ghost organs, which are organs that have been cleaned of their constitutive cells, but leave their extracellular matrix behind, which leaves certain factors that allow those stem cells you were talking about to be coordinated. Ultimately, SOX2, TNF-alpha, et cetera, those are factors that have a very temporal component and a very spatially associated component. You're talking about adding claws, growing fins, et cetera, whatever. You're going to have to coordinate the cells in a certain way.
Agreed.
To know where we are at right now, in terms of what can medicine do today, Dr. Taylor's research really captures what you're ultimately going for. Because in order to grow these organs, once she decellularizes them, she needs to provide the factors to the organ's vestibule at a certain time and in a certain order. Right now, just being blunt with you, it is brilliant research, it is fiery research, and it is very difficult. The organs don't have coherent vasculature. Oftentimes the stem cells get confused, and they don't know that they're supposed to still be making the heart. They'll start making a kidney inside the heart. And that is where we are currently at with, you know, replaceable organs. And by extension, what you're ultimately looking for, which is how do you program a cell, induce pluripotent stem cells, how do you command the cell to do what you want it to do, even if it has the gene? I think if you know, I like, obviously, Hugh Herr's research. It's fantastic. He's brilliant. I certainly think, you know, as the individual up front said at the beginning, you know, I absolutely agree that you are much more likely to see human-machine interfacing before you see designed biology. But if you want to see where would it be worthwhile for this organization to fund scientists, to put money that you doubtlessly have and want to encourage, Dr. Taylor's research and the area that she sort of inhabits, that's where we're at right now. That's kind of the bleeding edge.
Fantastic. Could you actually maybe send me a message afterwards or something, just to make sure that I don't lose that?
Absolutely.
I'd really appreciate that. Awesome. Keiro, who is next? Someone was next.
This might be a better question for you since you're a biophysicist. If you don't, let's say you're square zero, you don't know where you're going, you don't know what to do, but then you just you're interested in the field, like research like this.
Yes.
Where would you start? First step you should take.
In terms of like being a professional in the field or just enthusiast?
It doesn't matter.
Either way. Well, step one, I would say, what you're all looking for, where this would all fall under in medicine, is regenerative medicine. Regenerative medicine is also where we would typically house things like design biology, is telling cells to do what we want to do under a certain, you know, chemical signal. Regenerative medicine as a field focuses a lot on this. You have the controversial figure up there who tried to extend her own telomeres and then was subsequently censored and barred from her national academy. So this all falls under regenerative medicine. The idea of commanding biology to reverse, progress, alter in some aspect. That would be where I would start. There are many good books on sort of like how to regrow limbs. Like where I think a lot of maybe this might be a good place to start as well as the conversation of how would we regrow and how would we reattach it?
Thank you.
Anybody else?
That's a really great question and discussion. I would love to have a more discussion on that on Discord with us.
Yeah, good point. So to that end, we have several people in our community Discord server that are very happy to give career advice. Like they will run up and give you career advice. So that's also a possibility.
When I was a kid, I learned that people were speculating about designer babies, back in 2006 or something like that.
Some people tried.
Yeah, and as a kid I heard about that.
I remember hearing about that.
I want to learn more, but I never knew where to start. So having a panel like this where people are talking about this discussion openly, I might try and join your Discord so I can just learn more and fascinated by this.
Yeah, actually, where can we get a link to that or anything? Because I'd actually.
Is that on the main webpage?
We have a website for that.
Yep. Yeah, we have a Discord submission form that is linked from our main website.
And is there any major requirements, or do you just have to be enthusiastic about it?
You have to be an adult. I think that we're all satisfying that.
I mean, you got to be an adult.
It's just something I definitely want to keep tabs on, and that's just.
Yeah.
Not even gonna lie, I had literal dreams when I was a child of brain transplants into animals. So this is kind of.
No, I get you. I get you. That I'm sure that's fun.
I'm gonna ask actually kind of bounces off that. What's the feasibility of actually just making a whole new body and transferring the person over, opposed to shifting everything? Coming from the mechanical engineering side of things, the simplest thing is just to go ahead and start a new structure from the ground up, make it just right, and put whatever the control unit is.
Yeah,
The problem with brain transplant is where you cut.
Do you mean like
Do you
clones?
cut from the spine down? Do you include the spine? That's the biggest problem in modern neuroscience when you talk about peripheral limb regeneration is where does the cut occur?
Yeah,
Because when you cut halfway up the spinal cord, it sends a suicide signal up the brain, and certain frontal lobe processes actually alter in the presence of that. It's one of the biggest problems to the millionaires who are like, cut my head off, freeze it, put me on a new body that doesn't have cancer or something. Because you need parts of the spinal cord. As far as the brain is concerned, this is not separate from the rest of you. You are one contiguous network spaghetti monster. So where the cut goes becomes sort of, and anatomically we've made these delineations, but the brain doesn't care about that.
Yeah. So the answer would be you'd have to cut outside the peripheral nervous system and ganglia. You'd have to cut like here. But then the difficult thing there is all of this stuff, like your organs, that is doing a lot to keep your nervous system alive. And if you're doing that, well, I mean that's half your body weight at least. So where are you really getting?
Complicated.
Yeah.
TM trademark. You
Yeah.
know.
Exactly.
I think that's it.
Yeah, question?
Okay.
So with the tails, obviously that's going to cause an issue with the vertebrae because of...
Can you speak up a little more, please?
A little louder, please. Sorry. Obviously with the tail, that's going to cause an issue with the nervous system because that's integrated with vertebrae. So would that relegate you to just using machinery from that point down if you were to go that route of using a brain transplant?
Complicated question. So with regard to control of the tail, that is, I would say this is getting a little speculative territory, but that should be a little bit easier to control the tail because you can just have some sort of a redirection of your motor neurons in the area. You either copy the signals they're making to existing muscles, then interpret them in some different way, or you steal some of those signals, then rather than copying them, you just kind of redirect them to the new musculature required the tail. The sensory aspect would be more difficult, of course, because
Yeah, particularly considering the human body that had remnants of it. Oh, really?
Yeah, like there is like plasticity, but at the same time, ascending neurons. I honestly don't really know how to answer that. Um, that has come up as a discussion point on the server a few times, and would probably honestly be worth its own project, because at the end of the day we don't really have, like, we have a few ideas, but nothing that would be like, yeah, that'll work. So
I think you've already talked with one of the people who has the foremost knowledge on that. You've talked with Hugh Hurst and his spinal implant. Those legs for that paraplegic patient don't send ascending signal, right? They don't have those motor neurons atrophied years ago. In the brain, there's not a lot of real estate, so if you don't receive trophic factors by repeatedly signaling, you die. So their motor neurons were gone generally a long time ago.
Yeah, I believe that. So then so in that sort of situation, that would be the solution for that would be that you have to have a brain implant, basically.
You need to get through human machine interfacing, right?
Yeah.
You need to find some way to replicate what
Yeah.
is not there.
Or new neurons derived from stem cells and have a really fancy ganglia of some sort. So
Fingers crossed on
yes.
adult neurogenesis.
Yeah. So whether you have to create a new structure for that ascending information, or if you can steal a little bit from an existing structure, then ask for plasticity.
No.
Okay.
It doesn't seem. I would say that admittedly based on my knowledge, and don't take my word for it, but trying to replicate a signal that's already there, it has a destination. It has a partner in the circuit, in the network that it's trying to.
Yeah, that's true. That's true. And like the motor and sensory stuff is pretty well stereotyped, so it's not really central to the plasticity.
Human medicine would pour billions and billions of dollars into regenerative medicine of the peripheral nervous system if there wasn't hope. And the biggest hope is that because the central nervous system is plastic, or the ability to adapt, evolve, and grows. The peripheral nervous system doesn't need to be that plastic, right? It has a function, it has a utilitarian value. It needs to move my hand when I command it to do so. That means it follows a much stricter blueprint. So when you sever a motor neuron, if I were to cut my arm off, the arm would not grow back, but the nerve that connects and innervates this area would. It would generally know where to go. There are some problems when you get down to finer capillary beds, and there are issues with how that signal is reintegrated, which causes the peripheral neuropathy. But generally speaking, that is a much better starting place than adult neurogenesis within the central nervous system, which is a product of how it was created.
Yeah.
So, I would say if we have general hope that we can reattach, reconnect biological limbs, then the next extension of that would be designer limbs, the designer nervous system.
So that is definitely one approach, and I share your relative optimism for peripheral nervous system manipulation as compared to central nervous system manipulation. But at the same time, it's still worth remembering that it's. Okay, thank you. I don't think that you would have to ask something like cut an arm off.
I'll just use that as an example.
Okay, yeah.
Just the type
Because if you're messing with the scales of, like the size scale of this tissue, then that seems easier to me, and this is again an opinionated territory, than trying to develop something new than creating an interface. But that is another thing for the roadmap. So yeah.
That question.
I think it was already answered.
Okay.
It was about the idea of, or the concept of maybe having machine nervous system interface that would be external of the body, but attached to the body in some way. I'm not explaining it well enough.
So like a prosthetic.
Like a prosthetic, but it's over you. Like an exosuit, but not really. Like it's.
There's groups working on stuff like that.
Yeah, there's like someone who's working on a second thumb.
Yeah, I actually I heard on public radio like about half a year ago talking about a group of researchers that gave people like second prosthetic thumbs, and the whole idea that they were trying to answer was, is there enough plasticity in the brain to allow them to have complete motor control over them? And what they found was astounding from what the radio article said.
Now, do you mean like independent?
Yeah, I believe I don't know entirely, but they did mention an individual extra, like an extra thumb, like you would expect. They said that most of the participants did not want to give it back, and many of them were willing to fight for it, basically.
That is amazing.
Like they felt actual loss, like a loss of a limb, when it was removed.
Huh. That
Like,
is
it literally became
fascinating.
part of their body, and that was astounding to me because I was just delivering pizza at the time. I'm just listening. I'm like, holy crap! This is like what I've been dreaming.
That's amazing.
So, I mean, I've always been a proponent, and I know there's probably going to be some controversy in that. I think we don't give the brain necessarily enough credit as far as adaptability goes, but I think that there's definitely some burgeoning fields in here that are going to be some pretty big proponents for this entire field of research very soon.
Sounds awesome.
Right, it's crazy. We should probably get going. Honestly, thank you for the talk, though.
Thank you.
Before we leave.
Absolutely.
Thank you so much for coming. Thank you.
Yeah. I think that's a pretty good stopping point.